Hello, everyone. This is the last lesson for the quadratics module, so let's get right to it. The lesson is on quadratic applications. So let's talk about an area application. So apparently there's this rectangle, and I guess before I get started with the problem, let me say, if you can solve this in your head, if you can guess and check, then, the point is to solve the problem. So solve the problem. But make sure you learn also the quadratic application for this. So let's say we have a rectangle, all right? And I'm going to call this width, and I'm going to call this the length of the rectangle. And some people write it backwards. Okay, so it says that the width of a rectangle is 1 unit less than the length. Okay, all right. So notice how for the width, it's relating the width to the length. That means that we can write the width in a different way. We can write it in terms of the length. So the first thing that I try to do with this is establish one variable. All right, one variable. All right, I do not want to have a situation where I have more than one variable, like a W and a L. So it says the area of the width of the rectangle is 1 unit less than the length. So I can say, okay, the width is really the length, take away 1, right? Whatever the length is, it's 1 less, okay? And then it gives me another clue about this. Okay, the area is going to be 20. All right, then it asks, okay, so what's the width? See if you can solve it. Well, let's talk about what we can set up with this. Well, if the area is 20, we know that area is equal to length times width. And we just established that we want only one variable, right? So the area we know is 20. Let's fill in what we know. The length is just the length, right? But the width is really expressed as L minus 1, right? So what you end up having here right here is 20 equals, let's go ahead and distribute this L. We get L squared minus L, all right? And if I know a thing or two about quadratics, I know that I should set them equal to 0. So I'm going to take away 20 from both sides. So I have L squared minus L minus 20, all right? Which ends up being a very simple quadratic to factor. It will factor into L minus 5 times L plus 4, all right? Set it equal to 0. Find the zeros. So L equals 5. That's one of my solutions. And L equals -4 is my other solution. All right. So the question is, what's the width? Well, I'm not even going to consider a negative length because that's not possible for a 2D figure. But I am going to consider that the length is 5. All right. So if my length is 5, then if the area is 20, that means that the width should be equal to 4. All right. Now, some of you guys would have maybe guessed and checked and found that rather quickly, but it's important to know how to turn this into a quadratic application. All right. Let's look at another possibility for this. Another possibility. So I'll clear my drawings here. Okay. And I was using the other annotation tool. All right. So the other possibility is, what if we just have a numbers riddle? Okay, so this one says 5 times a number is 14 less than the square of that number. The hardest part is putting this into an equation. The rest is review. So 5 times a number, well, let's call that number x. 5 times a number is, that's an indicator of equals. 5 times a number is 14 less than the square of the number. So this is a little tricky, right? When it says 14 less than, all right? That does not mean 14 minus, all right? Because that would be taking away from 14. If it's 14 less than, then we're going to take away 14 from what? The square of that number. Well, the number was x, so the square of it is x squared, and now it's quadratic. Now this becomes a simple quadratic equation, which I set equal to 0. I say 0 equals x squared minus 5x minus 14, which is a simple factoring problem. So I'm going to say that is x. Let's see, two numbers that multiply to -7 and add up to -5. That's x minus 7 times x plus 2. So x equals 7 is one of my solutions. The number could be 7, or the number could be -2. In this case, I'm asked for the negative solution. So my final answer is x equals -2. End of story.